I'm Andy Leeb, and I'm going to talk to you about Guillotina Kafka. It's a story about an add-on. I'll talk a little bit about the reasons why we developed it, where I work, who I am, and we'll get into the use case for why we built this software. I'll talk a little bit also about the software that the software that we build and the company that I work for, and so the use case, and then I'll talk about a little bit about Guillotina and Kafka themselves, and sort of give you a little bit of an overview about that. So I'm Andy Leeb. I work at Ona. I'm a platform engineer, back-end Python developer. I've worked with Plone for quite a while now, probably around 10 years. And so I've served on the Plone Foundation board as well. So anyway, enough about me. And so I work at a company called Ona, and we use some Plone technologies. In particular, we use Guillotina as one of our linchpins to our software stack. And we have built out a fairly significant complex platform that we use in the legal service. And so I'm going to describe a little bit about what we do at Ona, and this will help sort of give a general idea of why we ended up having to work with Kafka. So Ona, in a nutshell, we gather cloud data sources that you're authorized to see and make it searchable. And so it sounds very simple, but we have a fairly deep microservices stack that we use, and so we can gather data from cloud sources like G Suite and Gmail and Box and Dropbox and Slack and stuff like that. And so we leverage the public APIs for these integration agents so that we can pull in the data automatically. They're long-running processes. And then when we get the data, it's analyzed and indexed through a series of processing steps. And all of this allows us to search the data, allows you to search your data in one place. And so typically, the software is used by in-house corporate law firms, and they use it for discovery and for legal holds and for risk management. And so this allows them to perhaps implement things like data loss prevention, or to make sure that corporate stuff isn't leaking out. But there are other use cases as well that as time goes on, our clients tell us about. But so anyway, we have a platform that we've built, and it's based off of microservices. And so we have, as I said before, we have these integration agents that go out and pull the data in. We do document processing. We do search and indexing. We have a front-end application that does the front-end stuff. We have Guillotina itself is our REST API server. We have a series of Guillotina-based applications as well. In addition, we also have stuff like AIO HTTP apps. We have a RabbitMQ, Kafka, of course, Elasticsearch, task queues, async IO. I mean, we have a lot of stuff going on, and it's all orchestrated through Kubernetes. We put things in Docker containers and use Kubernetes to deploy it. We have a pretty significant sort of deep microservices stack that we have to do. And so across the board, our API understands JSON, and so we're fairly typical in that sense. So we use Guillotina as our REST API server. So I think that everyone's fairly familiar with it, so I'm probably not going to spend too much more time on it. But as you know, it's built with async IO. It's the ZCA reimagined. So it's familiar to anyone with a ZOP or Plone background. We use it to store our data basically, and we validate our data and all that stuff with interfaces and JSON definitions of things. And so we can talk more about Guillotina if we need to later. But probably a little bit more germane to this is a little Kafka overview. And so we recently introduced Kafka into our software stack, and we've had a little bit of a learning curve with it. But so anyway, Kafka is essentially pub sub message broker. and it will guarantee delivery of messages in a specific order. So LinkedIn wrote it and then donated it to the Apache Foundation. And so they used it essentially to record website activity. And I think in the process of doing that, I think the more use cases were realized. So anyway, it's implemented in Java and Scala, and it is a pub/sub-based messaging system used to exchange data between processes, applications, and servers. So, like I said, its use cases include, but definitely are not limited to like a distributed commit log, like a website activity tracking, which is what it was originally built for. But it can also be used for log aggregation, and there's even more use cases for it that we're using as a buffer, for example. But anyway, so it runs in a cluster, and the cluster itself requires a manager called Zookeeper, which keeps track of the status of the Kafka cluster, the nodes in it, and make sure that the stuff that's going on in Kafka, like particularly the internal stuff like topics and partitions and stuff like that, are kept in order. And so it's a fairly complex piece of software, but it's really robust and it's really performant. And essentially once you configure it and tune it, it generally does not require a whole lot of hands-on, but getting to that point does take quite a bit of effort. So a little bit more about Kafka, just some terms that'll probably come in handy is, so a producer, which is what sends messages to a topic in Kafka, and a consumer receives messages from that topic and then does something with it. And that's really what we're focused on. But a topic is a named entity within Kafka that stores a message. And then a little bit smaller than that is a topic partition, which topics are split into partitions, which allows you to split data across multiple brokers or across a distributed cluster, essentially. So what does all this really mean? So essentially what happens is you have a producer that writes to a topic in the Kafka cluster, and then the consumer reads from that and does something with it. And so this is all sort of done in a guaranteed order, and so Kafka can keep track of where the offset is for the last thing it read. And so you can set a retention policy on a topic that allows you to say, if you wanted to hold on to that data indefinitely and something happened to the thing that the consumer was doing to the data, you could go back in time like to offset 0 and replay everything, and you would never lose any data. So I mean, essentially that's really one of the main reasons why it's so robust and so great. But anyway, so the data that's exchanged through Kafka, through the producer and consumer interactions, are typically called messages. And we use JSON, but really any data format works. It can be whatever's easiest for you, whatever's easiest for you to validate. And like I say, for us, it was JSON, because that's what our API was already doing. But so why then did we need to have Kafka if we had all these other services running and things seem to be running along pretty way? Was it just because we like added complexity? Do we like things that are more complicated? Do we want to sound cool, more knobs? All of those things are probably true, but really what we needed is that reliability of each message being guaranteed to be delivered. And so, as I said before, you can replay these messages if you need to, so that way you have a guarantee, even beyond the guarantee that the software already provides, that you will always have that data so you won't lose anything. Another big reason for it is that we realized that with our Elasticsearch, that it was fairly easy to overwhelm it with too many requests. And so when we're gathering data, we're pushing a lot of stuff through the processing pipeline, and it all ends up in an index in Elasticsearch. And if you give it too much to do, it might silently drop things. And so, this seemed to be a way to guarantee that we would always have data, that would always be, correct, that we wouldn't have any syncing problems between our object representation and our search engine. Another reason why we decided to do it was also for user activity stuff, which is, one of the express use cases for Kafka. But we wanted to be able to keep track, not just keep track of what people are doing, but sort of have an audit log that would allow our clients to go back through and make sure that they knew what what activities happened on the platform while they were using it and what the users are doing. And so this is actually really great for us because since we're dealing a lot with lawyers, they have specific requirements for how long the data needs to be kept. And so we can then have a specific retention policy for a topic that the data gets written to and read from. Another thing that we ended up finding out through just a little bit through trial and error, but more through observation, is that sometimes we would notice that not all the logs that we expected were showing up in our logging platform. And so we wanted to ensure that all application logs were getting written somewhere that we could guarantee that they would be there. And it wasn't like we were losing a lot of stuff, but we realized that perhaps we could be doing a little bit better. So we also implemented Kafka as a logging buffer. So those are some of the use cases for why we decided to implement Kafka. And another thing that's kind of nice about Kafka is that it's platform agnostic, and so you can pretty easily write a simple producer and consumer and not have to worry about what the other services are working with. But we thought that it would probably be better for us to be able to leverage Guillotina's ability to have add-ons. So essentially what we did is we did so. And so we built it using the fairly standard template for Guillotina add-ons. So as we built this, we really wanted to accomplish a couple things. And one thing that was really good is that we could leverage Guillotina and its component architecture. And so that allowed us to have a common vocabulary of code and reuse that we use. The other main reason was that we realized that the majority of the time was going to be spent building producers and consumers, and we wanted to alleviate some of the burden of having to create them and then integrate them into every single package that might need it. And so we figured that since we already have Guillotina deployed, that in our software stack, that we could leverage that and then just have this add-on that was fairly easy to that would allow us to easily create these producers and consumers. So what the add-on did is it provided two APIs to us, one for the consumer and one for the producer. And like I say, we mostly leverage it for multiple consumers. It uses ECA concepts like utilities for singletons and adapters for adding functionality and interfaces. Obviously it integrates with Guillotina because it's Guillotina add-on. One of the other advantages is that it's based on AIO Kafka, so it's async native. It plays well with Kubernetes, which is very important for us. And so, with this, the other thing that we really needed to make sure that we could do is be able to scale up the number of consumers, because as the load on our processes increased and we had more requests, we wanted to make sure that we could handle all that data, which was essentially the whole point in having Kafka introduced into our stack. And so before we wrote the add-on, we were doing one-off producers and consumers, and that's okay, but it's a little bit too much maintenance. And then furthermore, it's kind of hard to scale because then you have to continue to put those same, more consumer pods up in your Kubernetes cluster. So one of the things that we did to sort of as the evolution of this went on is that we made it the ability to have multiple consumers in a pod. And so what that meant is that we could have a single package with multiple producers in it, and then deploy it into our Kubernetes stuff, and then we could scale that way up if we needed to. It's good in the sense that it allows us to not have a lot of individual consumer packages, which is added maintenance, and there's more pods and stuff, and so we can have multiple consumers in a single pod, and then we can scale that up and down as needed. But the other thing that we sort of noticed about this whole thing is that most of the consumers essentially do the same thing, where they read from a topic and then put it into the next component. A lot of the times it's putting it into a specific part of Elasticsearch. And so, multiple consumers in a single package is actually really very powerful for us. did I mention that it makes it much easier to scale? Because that was really something that we found that we needed. So anyway, what did we learn about all of this? We learned that it's helpful to have it a way to easily create producers and consumers in sort of a predictable way. And it's the add-on also provided just enough framework so that we could easily customize what the consumer does. We did learn that, of course, scaling is important because it always is. But one sort of even bigger lesson that we learned from all of this is that just being able to create a producer and a consumer easily and being able to customize it is only a small part of it. That there was a significant part, a significant amount of time spent tuning Kafka itself and making sure that it was behaving the way that we wanted to in a predictable fashion, that it wasn't taking too many resources, and that we could that we had it tuned in a way that it could easily handle all the load. So that was a big part of it. It wasn't necessarily part of the add-on. It just so happened that it all sort of happened at around the same time. And so one other thing that we sort of learned from it is that we could probably do a better implementation that maybe wasn't a Guillotina add-on, that was maybe just a library that we could easily integrate into one place in our stack instead of necessarily having it as an add-on. So we did sort of look at what the next steps would be with it, and so like I say, we took looking at package called FOST, which does essentially a similar thing, but is a lot more overblown than what we need. But looking at the way that they did their sort of Python Kafka integration stuff, we could probably do it with decorators instead of having to have an add-on. And we could, like I say, we could build it as a library instead of an add-on, but not to worry, we're probably going to continue working with the add-on. So that's pretty much all the things that we did with Guillotina and Kafka, in a very quick overview. So do we have any questions?
Hi. It was nice to see like this integration. As far as understood, you collected data inside of Guillotina, right?
Yeah.
So did you thought about using like a CDC solution, like to capture this from the database chains, or why it's better to do this way or not for your user case?
Well, we found that this was a little bit better than what we had before, because the way that our software works is that we do store the data and the object representation in Guillotina, and then we would sync that with Elasticsearch. And the job that did that, was kind of processor intensive, and so we figured that this is probably a little bit better than having to run a background process. And so this happens a little bit more closer to real time. And so we felt that the results also in the search were improving a little bit with this.
So, what is Kafka, Andy? Just kidding. Related to that, Elasticsearch, for example, it's really important to batch update and reduce the amount of concurrent updates to things. So, like Elasticsearch, we couldn't handle all the load that Guillotina was pushing into it. But I did have a question for you. Did you want to talk about monitoring Kafka and some of the things that we had to do in order to see where we were on the Kafka offset and in terms of processing?
Yeah, I mean, I can touch on that a little bit. So, full disclosure, Nathan works with me and had done quite a bit of the engineering on, a lot of this Kafka stuff as well. So we did, have to monitor what Kafka was doing in order to get some idea of the performance that we expected from it. And essentially we needed to have a little bit better integration into our main application in order to have that visibility. And so in order for us to, essentially like we weren't able to customize the add-on in order to get, some of this, like figuring out where the offset was, that had to actually be done as a customization to the producer or the consumer in the application code. And so that's a little bit about on the customization that we allowed with the framework that we had. So I mean, it's a little bit of a non-answer, but that's essentially the level of detail that I feel like I could provide at this point.
Yes, I find it very cool to know again Kafka. I went to a meetup local where I come from a few weeks ago, and there I got a whole presentation on Kafka, on banking accounts, and also. And one of the things that came up there, that if you want to replay all the messages that have come into a topic and you have to go back, Kafka stores the messages. So when I hear you and you say, look, we want to go back to 0, then you now have 2.5 places where you store it. You store it in Guillotina in a database, then it goes to Kafka, and Kafka has to have a copy of the thing. And then, Elasticsearch is not really storage, but it's a huge index, of course. But now you effectively double the storage you need, right?
Yeah. Yeah, essentially you do. And so it depends on how long you want to retain those messages. And in some cases, you want, forever maybe. And in some cases you may only want a minute. So it all it depends. And since we consider the source of truth to be in our Guillotina application, that's more important for us for a lot of these things. And so there are, certain clever things that you could do depending on what your data is and the messages that you send to Kafka in order to trigger, whatever to be re-indexed. But the sort of like the backing the offset up to 0 and replaying everything would be done in this if there was a catastrophe, right? Like if you lost an index, or suppose you wanted to do a migration and you had a new version of Elasticsearch or something like that, and you wanted to, more easily like not try to move in between versions, and you could just take the data from day 0 and run it into there. So that's more the use cases that we had in mind, but you are correct in that it requires additional storage, particularly if you want to retain the data for a long period of time.